Now 7 segment display. Now 7 segment display we are using to indicate in numerical information. With the help of 7 segment display, we can display number 0 to 9 as well as few characters such as A, B, C, D up to F. Means you can display all hexadecimal numbers on 7 segment display, and this is the structure of 7 segment display. There are 8 segments are there. 8 segment is nothing but 8 LEDs are there. They are arranged in this fashion in form of 8. Okay, and one more is a decimal point, and this is the pictorial form of 7 segment display. Then next is application of 7 segment display. We are using 7 segment display for various applications such as a digital clock, electronic meters for displaying numerical reading, instrumentation panel, digital readout display. In this fashion you are using 7 segment display for various application. Normal application is calculator also. Okay, here in calculator also we are using 7 segment display. Now basic structure of 7 segment display. In 7 segment display there are 8 segments are there, and name of that segment is A, B, C, D, E, F, G and H. H is nothing but your decimal point. In this fashion, suppose in calculator you want to display 5.1, you can connect to 7 segment display. On first segment you are displaying 1, and on second segment you are displaying 5 decimal. Okay, means yeah, overall it is looking as a 5.1. In this fashion you can display any number along with decimal point with the help of 7 segment display, and for that you are taking help of 8 LEDs which are arranged in this particular fashion. Okay, now these LEDs, 8 LEDs are connected by two ways or two configuration, either it is common cathode or common anode. Now we know that common cathode configuration, in common cathode configuration all cathodes are connected together. Okay, and it's become a common cathode and it is connected to ground position. Okay, now under this condition, when this common point is connected to ground, when you want to turn on the LED to particular terminal, we are providing particular data. For example, suppose you are providing here 1 at a terminal, that time this is 1 and this is 0, and that time current will flow through this LED, respective LED, and when current is flow through this respective LED, that time this is glowing. Okay, means 1 is on, means when it is 1, that time this LED is on, means it will glow, and that time current is moving from A to ground. Okay, suppose we are providing here 0 on a terminal. In that case, this terminal is 0 along with the other terminal is also 0. Both are equipotential, and that's why current will not flow, and that's why LED remain off. In this fashion, under common cathode configuration, when you are providing here 1, the respective LED will turn on. When it is providing 0, respective LED turn off. This is the basic knowledge regarding common cathode. Next configuration is common anode. In common anode configuration there are 8 LEDs. Okay, and these 8 LEDs are all anodes are connected commonly to the VCC. Okay, and other end is A, B, C, D up to H. Okay, now here suppose A terminal, this A terminal is connected to our controller. For example, in our case our controller is 8051, means A is connected to one of the port pin. Okay, suppose through controller when you are providing to this A terminal as a 1, that time this is 1 and other end is also 1, and that's why current will not flow through the LED and LED remain off because both are equipotential. Okay, when controller send here 0, in that situation this A terminal is 0 and other end is VCC, and that's why current will move from VCC to ground, and that's why LED turns on. Means in common anode configuration, exact contrast, here 1 means off and 0 means off. 0 means on, 1 means off. Okay, means common anode and common cathode, that is the difference. That is in common anode 1 means off and 0 means on. Now these 7 segments are connected in this fashion, and these are the terminals. In common anode, this is connected to our controller, that is 8051, one of the port of 8051. We know that in 8051 there are 4 ports, that is port 0, port 1, port 2 and port 3. You can connect anywhere these pins, that is terminal A to H. Okay, when you are connecting this and you dump that code, that time you are getting the output. Just see here, now 1 is displayed, 2, 3, 4, 5, 6, 7, 8, 9, then 0. In this fashion we created the hex counter with the help of 7 segment display. Here we are displaying number 0 to 9, and after that again it is 0 to 9. In this fashion we are displaying, we are constructed here decimal counter with the help of 7 segment display. That is one of the problem statement. Okay, now we want to develop the number from 0 to 9 in a BCD counter or decimal counter, and 0 to F for hex counter. As per our application, we are just developing this code to display proper number on 7 segment display. Now suppose I want to display 0 on 7 segment display, that time all these LEDs must be on except G and H. H is nothing but your DP, that is decimal point. Means only G and H must be off and all other are on. That time it is showing 0 on the 7 segment display. Okay, when you are displaying only B and C are on and all others are off, in that situation we are observing 1 on a 7 segment display. When we want to display 2 on 7 segment display, in that case F, C and H are off and all others are on. That time we are getting 2 on a 7 segment display. In this fashion we are getting number on 7 segment display. Only just see here regarding letter point of view, A it is capital letter, B is a small letter. Suppose you are written here capital letter, then it's become same as a 8. To avoid the confusion, we are taking B in a small letter. Similar way D. Suppose you are taking D in a capital letter, it's same as a 8. To it is to avoid that we are taking it as a small letter. Then E and F. In this fashion we are just developing our code as per the which counter we want to design. Okay, and that code we are keeping in one lookup table, and we are calling one by one that number and pass to display, and that time we are getting number 0 to 9 on 7 segment display or 0 to F on 7 segment display. Now we already discussed, I already shown application related to common anode configuration. Now in practical we are just doing common cathode configuration. In common cathode configuration means all cathodes are connected together and it is connected to ground. Okay, in that situation this A, B, C up to H, all these terminals are connected to, it is coming from the controller. Okay, when you are providing here 1, in that situation your LED remain on, and when you are providing 0, LED remain off. Means in common cathode configuration 1 is on and 0 means off. Okay, now just see here this figure, as per your requirement, just provide the signal on this pin, according to that particular number will display on 7 segment display. Now how to create the lookup table, that is the question. Once you get this idea, then you can construct that lookup table as per your requirement. Now how to construct that is the question. Now this is your 7 segment display, that 8 segments are there, that is A, B, C, D, E, F, G and H. H is nothing but your decimal point. Okay, now I want to display 0. When I want to display on this 7 segment display 0, in that situation I don't want this G and H, means these two must be off, that is H, G and H, and that's why off means this must be 0 because it is common cathode, and all others we want on position, means we are providing here 1, means control will provide here 1. Just see here lookup how to create the lookup table. You are just writing the letters A, B, C, D, E, F, G and H. Okay, which device you don't want, you want to make it off, make it 0, and all others are 1 1 1. For to display 0, I don't want G and H, and that's why I'm placing here 0 0. Means these two LED remain off and all other LEDs remain on, and that time we are getting here 0 number on the 7 segment display. And okay, now once you are written this thing, just calculate what is the lower nibble. Now this lower nibble is nothing but F, that is 1 1 1 1, that is F. And what about upper nibble? That is 0 0 1 1, that is nothing but your 3F. Means when you are providing 3F as a code to 7 segment display, it will display 0 on the screen. When you are providing 3F, that time G and H are off and all other LEDs will on, and it will display 0 on the screen. Okay, now next number I want to display, that is 1. Okay, for to display 1 on 7 segment display, in that case I want to turn on only B and C segment. All other segments I want make it off, and that's why to B and C I am placing here 1 1, and all other cases I am placing 0 0 0. Okay, now again, once you written all these things, just calculate your lower nibble and upper nibble. Now lower nibble is 0 1 1 0, that is nothing but 6, and upper nibble is 4 0, that is 0 6. In this fashion you are just calculating the number is 0 6, and it will turn on only B and C. B and C will turn on, it will display 1 on 7 segment display. In this fashion, just calculate all numbers 0 to 9. Okay, and according to that just calculate your hex code. Then we are just writing this hex code in our lookup table. Okay, and suppose you are want to develop hex counter, just write number 0 to F, where B and D are small letter, all others are capital letter. Okay, just construct your lookup table and then we will see the code. Okay, I will explain the code also, and then now this is the common cathode. Your number you are calculated 3F. For 1 you are calculated 0 6. In this fashion you are calculated for all other numbers. This is for common cathode, whereas in common anode exact contrast is coming in common anode. Means whatever 1 is there, it's become 0 0, and where is the 0, it's become 1, and according to that number you are getting other hex code for common anode, exact contrast of common cathode. Okay, because in common anode 1 means off and 0 means on. Now according to that we will write the code for interfacing 7 segment display with 8051, that is single 7 segment display. On that we will display hex counter as well as decimal counter. Second problem statement is we will interface multiple 4 7 segment display to generate number for all zeros to all 1. Okay, in this fashion we can construct the 7 segment display with the help of this two problem statement. Just complete your lookup table, and then we will discuss the code part. Or may I explain the code also? Okay, I will just show that part also. That is the interface 7 segment display to 8051. Now this is the figure. This is 8051. One of the port is connected to 7 segment display. Okay, now next part is you want to develop hex counter or decimal counter. According to that I will write the code. First we are writing the code in C language. We are using a 5.1 header file. Then we are just declaring the segment is connected to which port. I am referring port number 2, and that's why segment means we are just defining segment. Where is the segment? Where is the 7 segment? That is segment is connected to port number 2. Then we are just calling the delay in C language. Okay, what that is N. Next point is we are writing the main program. In main program we are just using one variable, that is I, and then this I variable is its type is unsigned integer. Okay, then next is we are creating the lookup table. Whatever number you are hex code you are calculated, you are just putting into the lookup table. Okay, first number is 0, its code is 3F. Then second number is 1, that is 06. Next number is 2, its code is 5B. 3, 4F. In this fashion you have just calculated all the number from 0 to F, and you are just putting into the array whose name is segment. Means one by one you are just writing all numbers into the array whose name is segment, and all numbers from 0 to F. Okay, now one by one you are taking the numbers from this array and pass to display to develop hex counter or decimal counter. Now in this case we want to develop hex counter, and that's why you are varying from 0 to 15. Means that's why I'm just writing here for loop, and before that I'm just writing while one loop, because we want this loop for continuation process. I don't want to display from 0 to F only, I want to remain in the loop continuously, and that's why I'm writing here while one loop. Then in for loop, how many digits are there? 15, that is 0 to F, and that's why every time I get incremented. Means first number will display, then second number, third number, fourth number, up to last number, up to 15th number will display. Every time take the code from this array and pass to segment, that is nothing but port number 2. Then give the delay to see that number on the screen, and in this fashion this is your code. Okay, I will stop now the explanation of theory.